So welcome to LineTraceSingleByObjectType. In this video, we're going to meet references for the first time. That's when you see an ampersand. We'll be using, well, no, we won't be using LineTraceSingle because it may be deprecated. So we're going to use LineTraceSingleByObjectType. We will build our parameters, including something called an fCollisionQueryParams object. And there's a couple of places you can go looking for documentation. One is there, and the other is there. Sorry, that's a little hard to read at the bottom, but I think you can see it clearly enough. So without further ado, let's dive in. By the end of the video, what we'll be doing is as we walk up to objects like the table and the chair, if you look in the output log there, you can see that it's recognizing that we're hitting those and logging it out, but it's not recognizing walls and doors. So let's do it. So here we are, ready to do our raycast, or in other words, a line trace. I'll put raycast in brackets in case you want to search for that. Remember your future self and what you might want to search for. Okay, so what's the method and how do we find it? Well, the method actually applies to the world. We're going to be line tracing in the world. So firstly, we get world. And then we see what we've got. So I'm just going to do a search for trace and see what we have. All sorts of stuff. Here you go. These are the ones we want. We have line trace multis and line trace single. Now, a line trace multi will pass through multiple objects and report multiple answers. So if you look at the signature for this one, you can see here we have an array coming out. Okay, so we want line trace single by object type. Remember, we were going to be sorting for the object type, which is the physics body over here. You see on the table. And then just to recap what we talked about before, collision and then collision presets, object type of the table is a physics body. Okay, so that's what we want to filter for. So we're going to look for the method that is line trace single by object type. Now be careful. If you use line trace single by channel, for example, it will appear to work, but it will ignore your filter and it'll return all objects. So just a word of caution there, use the right method. There are actually a couple of methods which have different names but behave almost exactly the same. All right, so what do we do? How do we do this? So let's open up the brackets just to get our exploration going. Give ourselves some space. The first thing is we need an out parameter called an fHitResult. So let's go create one. Here we go. fHitResult line trace hit. Something like that. All right, or you could just call it hit. That's what you're hitting. So we could just call it hit nice and concisely. fHitResult hit. So that's our first parameter, but it's an out parameter. So I'm going to mark it as an out parameter. Out hit. Okay, now once Visual Studio catches up, what do we have next? The start. So the start is the player. Viewpoint location. What's the end? Well, we've already made the end. It's the line trace end. Cool. Then what? Now it wants an collision object query parameters, and there's an ampersand in here, like you may have seen an ampersand in a couple of other places, object query params. Okay, so let me explain what this ampersand is firstly. This ampersand is a reference. So introducing references. References are special pointers denoted by an ampersand. They can't be null pointer or any other null value. You'll discover with pointers later that we can point them at nothing, not the case with a reference. They can only be assigned. They cannot be reassigned. So once you've assigned a reference to a particular object, that's it. It's stuck with it. And think of them just like an alias. You basically use them just like the object they reference. So they're not too scary. They behave very much like an alias to the object they're referencing. Okay, so back over here, the next type of parameter that it says we want is an fCollisionObjectQueryParams. What is that? Well, let's go take a look at it. Now we can do this right in line here. So let's go fCollisionObjectQueryParams. What is this then? It's a structure that contains a list of object types the query is interested in. Okay, so let's just write that type and then open the braces to get the constructors. What have we got? We've got one here. In objects to types to query as an int32. That looks horrible because int32 does not look like a good way to encode an object type. This one takes no parameters. Don't worry about that signature type for now. Or that one. But this one here will construct a set of query parameters based on a collision channel. That is the one we want. All right. So again, just look at this signature and go, well, how on earth would I make any progress here? We'll just try typing collision channel. What is that? It's an enum So colon, colon to access its members. And then if you start typing PHY for physics, we have ECC, i.e. collision channel physics body. That's how we tell it. We want to only look at physics bodies. Finally, it wants an F-collision query parameters input as well. Not F-collision object query parameters, but F-collision query parameters. Now, I'm just going to show you how this works because it's the first time you've seen this. No good me challenging you to do this. I will challenge you to do the last bit of this. So let's do a couple of things. Let's firstly make. So set up query parameters. Now, by the way, with these comments, if you use double /, we're going to, like I have been, we create a small problem. Look at this. Let me zoom up to here. You see these two lines, get player viewpoint this tick, and then F vector immediately below. Look what happens if I hover over player viewpoint location here. It says get player viewpoint this tick because the comment that I've highlighted is binding to the declaration below. So for comments that apply to a whole block of code, you can use triple / to stop that happening. In fact, I'm going to get rid of my log there. And I'm going to put some triple / in here, and here, and here, and here. Okay? And that's just going to stop hit from getting the comment and the documentation of what's above. All right, we'll talk more about comments and self-documenting stuff later on. All right, so we have this F result hit, and it's an out parameter, yada, yada. So what we need next, as we say, just to recap, is something of type F collision query params. So let's explore this F collision query params thing. What constructors do we have? Open the braces. So this one here is asking for in trace complex equals false. What does that talk about? Well, let's talk about that parameter briefly. What this is about is if you do a complex trace, then the ray is going to go out and find out whether it intersects with this stuff, this detail of the chair like the arms. Whereas if you put false for that, so you do a simple trace, then it's just going to look at this collider. We're going to do simple. So when we see that parameter, we're going to use false, but we're not going to use this constructor because we want more control. I'm going to use this one. It's got the trace tag, which we're not using. Don't confuse that with any of the other trace. Forget what trace tag is for the moment. I'm actually just going to provide that as nothing. So I'm going to say fname, open braces, text, open braces, then just nothing. Okay? And then going carefully outside of there, I'm going to go to the next parameter. I'm going to put false for complex because we want to do a simple trace into the complex into these colliders, these simple colliders. Okay? And then the final parameter is it wants an actor to ignore. Well, let's just get owner. We're just going to ignore ourselves, right? So you wouldn't, this is tricky to use, but once you've done it once, that's a template for getting started with a simple trace. If you do want a bit to intersect with, say, the arms of the chair per the visibility collision, then you would change this false to true. We won't worry about the tag for now. And obviously you ignore yourself because if you look when the game runs and we eject, we have a finite volume, not that you can see us in this view. We have a finite volume and the trace starts from right in the center of this sphere. And if we don't ignore ourselves, the first hit we'll get will be ourselves. So we set up the parameters, now we can pass those in. Of course, we haven't given them a name yet. So F collision query params, give them a name, trace parameters, like that. Okay, and then trace parameters, and the semicolon on the end, keeping track of all our white space. And hopefully we then have something that's going to compile. Let me go to Unreal and compile it, and then I'm going to give you a quick challenge to do. And it will be a relatively quick and simple challenge. It's a logging challenge. I want you to log out what the actor is. But let's just check that our code compiles to this point. Taking a little longer than usual. There it goes. Let's just run. And it works, but we're not getting anything on the console because we haven't got a log statement. So I want you to log the actor hit. Get the actor pointer from the hit. The hit that comes back is quite a nice complex object, got a lot of information in it. So if you can get the actor pointer from that, perform a get name on this actor, and then log the name to the console, making sure it works. So when you walk up to the table or the chair or any of your other physics body objects, it should log to the console that you're hitting them once you're within a meter, and any other object like the floor and ceiling shouldn't. So let's explore this hit thing. Hit, what is it? It's an F hit result. It's not a pointer, so we can use dot. What can we get from it? We can get the actor. Fantastic. What does get actor return? A pointer to an actor. So let's do that. Let's say actor, a actor star, pointer to an actor, actor hit, equals hit.getActor. Okay, if I could spell right, then we'd be there. Now, a useful protection mechanism, and you don't have to do this, is to say if actor hit. It reads nicely, and it makes sure that that pointer isn't associated with nothing, so that if there wasn't an actor hit, we skip this code. So we're going to do a UE log again here, open the brace. Good old Visual Studio is completing the closing brace for us. We're going to make it log temp as usual. Warning verbosity, keep it in yellow. Format, so it needs text, remember? Then what do we put in here? Well, I'm going to say something like line trace hit colon, and then put a string in with the format operator, %s. After those braces, I'm going to do what? Well, I need to get the actor name. So we have actor hit, and then it's a pointer, so it's an arrow operator, get name, which is a method. Now we're nearly there, but I'm going to put actor hit get name in some brackets. Then point out that actor hit get name is going to return an F string, and that the UE log wants us to dereference those F strings with a star, as we've seen before. So that line there, carefully written, should give us the result we want. Let's go have a go in Unreal and see. I'm being lazy, I'm not even saving the file in Visual Studio, and something's gone wrong. Let's take a look. Line 73, unexpected end of file in macro expansion. So let's see what we're doing wrong there. I'm missing a closing brace. I didn't match my braces. Let's try again. And that makes sense, right? The error was unexpected end of file. It's because it was missing a brace. Okay, let's look around. Look at the floor, look at the wall, hit the doors. None of it's logging anything. But the chair and the table are logging. Awesome. We are now line tracing out and working out what we're intercepting. It's nothing to do with that red line you see. That's just a debug line. We could turn that off, but it's absolutely working, and that's great news.